This is Algebra 2 at Trig, 1B.4. We're going to be using the graphing calculator so we can interpret some graphs. What we noticed here for the first question is we have a water balloon, and it's launched from a dorm room. The height in feet after t seconds is given by our equation. So you could answer a lot of questions just using the information that we know of. Line of symmetry is negative b over 2a. We could find vertices. We know what y-intercepts are. You could answer a lot of the questions using the skills that we already know. But we're going to talk about how to use the graphing calculator. So before we start typing anything in, I would always suggest to say second plus 712. And that's going to clear your calculator. Okay, cleans it up. Puts us all in the same expectations. So we're going to go to y equals, and we're going to type in 128 plus 64t minus 16t squared. The minus 16 is like your gravity. That number's not going to change. It's going to stay at negative 16. But some of the other numbers can change depending on the situation. That'll typically be negative 16. What we want to do is look at our table. So we hit the second button and the graph button. Second graph. And that goes to table. If you notice, table is written in the same color as your second button. So because mine is blue, I have to hit the blue button first. And then I get table. So at 0 seconds, the water balloon is at 128 feet. It hasn't really been thrown yet. After 1 second, the water balloon goes higher. We're at 176 feet. 2 seconds, it seems to be at the highest point. And then it starts to come back down, and eventually it's below 0. Okay? So we're going to type in our values. We have x and y. We were 128 at 0 time. Then 176, 192, 176, 128, 48, and negative 64. Now you'll notice that the table keeps going on. You can keep going down the table. Why does the table stop after 6 seconds here? So if we're thinking about our situation of a water balloon with a height, our water balloon hits the ground at 0. So as soon as we're negative, we're under the ground. We're not worried about the height of the water balloon anymore. The water balloon hits the ground at y equals 0. So negative y values are past that. We can't get to be exactly 0, so we have to go to the next x value that's 0 or lower. And that's what we did. So if we think about graphing this, you're going to see 2 lines pop up, but that's not much of a graph. I can't see where the max or min number is. If we go to Windows, we can make some adjustments. The current window is negative 10, 10, and 1, negative 10, 10, and 1. You can always hit your zoom button number 6. That's the only reason why you would ever use this zoom button. Zoom number 6. And that takes it right back to this negative 10, 10. If you ever want to change it, you want it all to change at once, you can go zoom, and then you hit number 6 to Z standard. That would take it right back to the normal values. All right, so where do we need to change our values to? What can't we see right now? We can't see the maximum Y value. We know the maximum Y value is up here at 192. So if we go to Windows, we need to change our maximum Y value. I would suggest to plug in a number bigger than 192. So if anything else is written at the top of your screen, you can see through that. So let's say 120. You'll still see that your vertex is way at the top. But you're going to notice here in a moment that we're going to have things written on the screen over here, and it will no longer be covered up, or at least covering up our vertices. All right, so we know that we're going to do a Y max that's a little bit bigger than normal. You might find out that your Y minimum is going to have to change. We'll wait for that one. Your X's are standing for time. We don't need to see any negative time. But you don't overly have to change it. We'll be able to get our maximum and our 0, and this can all still be here. So I wouldn't mess with even thinking about changing it. The maximum for X, that's far enough out there. So I wouldn't worry about changing that much. And our scale, we see the little tick marks there for the scale. So that's fine. 1 is good. But it's this Y stuff that we're going to see changed here in a second. What is the height of the dorm room window? What height is a dorm room window? When t equals 0, the Y value is 128 feet. So on our table, or sorry, on our graph, the dorm window is on the Y-axis at 128 feet. It's at 0 time. 0 time has happened in the toss of the water balloon. What is the maximum? Find the maximum. Well, we can figure out the maximum just by looking at our table right there, because our Y values are repeating themselves. But that's not always going to be the case. You're not always going to have repeating Y values. This is the vertex only because 2.0, the exact value of 2, is the line of symmetry. What if it was 2.1, 2.2? We're not showing 2.2 on here, so it would give us a 2 value, and that would not be your maximum. And these would not be alternating the same number. But they are right now, but in a previous or a future question, they will not. Anyway, so let's practice finding it where we're somewhat confident of what the answer is. So we're going to go through this process. You're welcome to read it if you like. You're welcome to visit these links. So we go to, not even second, just go to graph. Now we go to second, trace. We're looking for the maximum value. So we go down to number 4 and hit enter. What's it say here in the corner? Left bound. You need to be left of where you think the answer is. And the answer is about right at the tip of the pencil. We need to be left of that. That's where we look like we are. any of these spots is to the left of the maximum. All these are to the left of it. X is smaller. So it doesn't matter which one. Hit enter. Now what does it say? Right bound. That means you have to get to the right of where you think the answer is. Doesn't matter how far right you go. Just go right of it. So I'm sure to go down my parabola sum. It doesn't matter how far. Hit enter. Now you have these. My calculator just shows triangles. Some of your fancy calculators will show lines coming down the page. That's kind of like your domain that you're looking for. The calculator's only going to look in between that when you tell it to look for an answer. It says guess right now. Guess is for when there's more than one answer. You have to get closer to the real answer. Well, we only have one answer, so it doesn't matter about guessing. Just hit enter. There it is. 192. Now notice how the writing is over the x-axis. We can change that. We can push our graph up more so we can see the x-axis better. So if you go to window, you can change your y minimum to maybe negative 25. Not even sure that's going to be enough. We do second, trace, maximum. Now you see, we can see that value with the numbers there. We can see the x-axis when you have the numbers being calculated. Left bound, right bound, and 0. Okay? If you notice, I now have a different value for x. The first time I had like 2.000001. Anybody else have that? Does anyone else have something different? What might you have? 1.999. Yeah, that's a possibility. Remember, you asked for the maximum value. You did not talk about what you were doing for x. You asked for the y answer, so it gave you the real y answer. And then for my explanation, as it goes back and forth trying to identify where the maximum is, it gets to an amount, and it says that's close enough. I bet I'll get a different one if I do it again. Maximum. I pick there. I pick there and guess. Up there. This time I got 1.999. Okay? So this is a super approximation, but this is the exact answer. So you need to understand that the line of symmetry is not almost 2, it's exactly 2. So we changed our y minimum to negative 25. That gave us a better screen to be able to see writing underneath it. But you see how we have like an extra thick y-axis? If you go to window and you y-scale, you can tell it to put a pixel every 25 or even 20 units. And there are the tick marks every 20 units. It does not change your answer at all. It doesn't change the graph any more than show you the little tick marks. So that's not overly necessary. You can ignore that. Okay, what is the maximum height? 192 feet. When does the balloon reach 192 feet? At 2 seconds. Okay? That's what we found out. What is the height of the balloon when it hits the ground? the height of the balloon would be 0. When does the balloon hit the ground? Well, if I come over here, it's the x value that is out here. It's the x value right there. You can see this approximately with the table. It's between 5 and 6. Seems to be where 0 would land. Between 5 and 6. So, what we're going to do is do second trace. You're looking for 0, so that's number 2. What's it say here in the left-hand corner? Okay, it says left bound. So we need to be to the left of where we think the 0 is. To the left of that. Well, I'm way over here, so I am definitely to the left of it. That's fine. Or you can get closer. It doesn't matter. I'm to the left of my x value that represents my x-intercept. Now I hit enter. Now it says right bound. I have to be to the right of it. Well, to the left of it, in this case, is kind of above the x-axis. To the right of it would be when you're below. Currently I'm at 15, then I'm -7, so I'm below it. That means my x's are to the right of the real answer. I'm still to the right of it, and I'll always get bigger now when I keep hitting to the right. So that's close enough. I'll just hit enter. Now it says guess. You're looking in a window that's in between these two triangles. Your calculator might have vertical lines coming down telling you that you're looking in between there. You only have one answer that's a 0, so you're just going to hit enter. And my x value is 5.46. 5.46 seconds. And then another type of question we ask is find the times, plural, rounded to the nearest hundredth when the balloon is 150 feet from the air. Well, let's see what that means. If I go to my table, I would have 150 feet between 1 second and 0 seconds. That's my 150 feet. Then I have another 150 feet between 3 and 4 seconds. So we're going to go to y equals, we're going to type in 150 because we don't know where it's exactly at, and hit graph, and there's the line that represents 150. You've got to put in the horizontal line. Then you can do second trace, intersect, because you're looking for the intersection of two lines. First curve like means equation. So first equation, hit enter. Is that your second equation? Hit enter. And guess. Well, this matters this time. If you want to be closer to the larger value of x when y is 150, you need to get closer to that intersection and hit enter. And it'll give it to you at 3.62. 3.62 seconds. Well, we knew there was another one. There's another one back here, so we need to do this again. Second trace, down to intersection, enter, first curve, second curve, and then we guess our way closer to the other one. Doesn't matter how close you get, just hit enter. When you're closer to that, and we got 0.379, so 38. Okay, our last question down here is revenue. You got to really pay attention to this question. We're going to make it as simple as we can, but listen to the process of this question. Revenue. What is revenue? Revenue is the amount that you make. So if you have a price of an object and you times that by the number of items, you're going to have a revenue. That might not be your income because you may have other costs involved, but that's revenue. That's how much you're bringing in. Depends how much you sell it for. A video store sells 150 DVDs each week at a price of $20 a piece. The owner estimates that for each $1 decrease in price, about 25 more DVDs will be sold. Listen to that again. You can't ignore that. For each $1 decrease, you're going to sell it for less money. You're going to sell more DVDs. 25 additional DVDs each week. How can the owner maximize weekly revenue? So I would start out with your price. Your price is $20. The number of items you're selling is 150. And that's going to give us $3,000. 20 times 150, $3,000. So that's our revenue, our current revenue. Can we do better than that? What are we going to do? What's the storyline suggest to do? Decrease the price by $1. So sell it for $19 now. I mean, you're not going to make as much money now. You're selling it for less. But you're going to sell more DVDs. That makes sense, maybe. If the price is cheaper, more people are going to say yes. So we're going to have 175 DVDs being sold. 150 plus 25 is 175. 19 times 175 is 3,325. We do it again. $18. 200 DVDs. 3,600. Okay. And you can see if we do it again, 225 DVDs. We still go up. So how far are we going to go up? Is it going to go up forever? So we feel like there should be a maximum somewhere. Okay? This is not the way I'm expecting you to try to solve the problem. You can keep going until you found it. Okay? What I would like you to do is write an equation. revenue. Our price was $20. What are we doing with this $20? We're going to decrease by $1. So we're going to minus. You're welcome to put in a 1 if you want. $1. One amount of times. We're doing a decrease. And for every decrease, what are we going to do to the number of items?
Increase by 25.
So we're taking our 150 and we're adding 25 every time we change the price. We're also changing the number of items we're selling by 25. So we can now go into our calculator, y equals. Now remember, we have a lot of things in here, so maybe it's just best to say second plus 7, 1, 2. All right, so we are going to go to y equals. We'll type in our 20 minus x and our 150 plus 25x. If we go to table, second graph, second table, you can see at 0 adjustments in the price, we're going to make $3,000. That's exactly what we said. And after $1 in adjustments, we made more and more and more. And it seems to keep going. Is it going to go forever? Do you notice that these are changing by less and less each time? That didn't change by much. And then you start to watch it come back down. Now it's dropping. So your maximum value is going to be inside your repeated y values. So yes, that is your vertex. How can the owner maximize profit? Sell each DVD for, okay, let's talk about it. For what price? For at 7. When you decrease by 7, you could say 13, you could say $7 off. Okay? Decrease of $7. We're going to sell each DVD for 13. Sell, how many are we going to sell? This doesn't tell us how many we're going to sell. But if we use our sell formula, or the number of items formula, 150 plus 2 times, or 25 times 7, that is 325. So we're going to sell 325 DVDs to max profit of $4,225. There it is. We answered it. You don't need to do all these calculations here, but I wanted you to see it grow. I wanted you to see what's happening. Here's another storyline. We might find out that this storyline doesn't work very well, but we'll discuss it anyway. You run a canoe rental business on a small river in Ohio. You currently charge $12 per canoe and average 36 rentals a day. An industry journal says that for every 50 cents increase in price, the average business can expect to lose one rental. Actually, two rentals. Use this information to attempt to maximize your income. So our revenue is going to be price, which is $12. What are we doing to that $12? We are, take a look, increase 50 cents. So we're adding 50 cents or 0.5 of a dollar. And we're doing that multiple times. So that's got to have the X on it. And then how many items are we selling? And what's happening to the 36? Lose 2. Decrease by 2x. So this time we were able to go right to the equation. You didn't have to write it. We're not trying to solve it using this method. One, it could be very repetitious, and if it came out to be 20 or 30, that would be very frustrating. This one's at the other extreme. So we'll go to y equals, we'll type in our 12 plus 0.5x, and our 36 minus 2x. And we can go to table. What do you notice? Let me get down to 0. What do you notice? The y values are decreasing all the time. So in other words, the maximum value was actually in the second quadrant. Okay? So you could say maybe if you decrease the price and you gain 2 people, then you could start to work backwards. Okay, but that's not what we're doing. All right, so I would say the answer to this would be you would keep the price the same. Okay, keep the price the same. I'm not sure that the pattern works going backwards for every journal type concept that they share with you. Okay, here's a journal they talked about. All right? So there's your equation. That's what we wanted to talk about how to write. Good job.